Okay, one of the exercises that we're going to do is exercise 29, which talks about a spreadsheet that can do affine encoding. Now the pattern is in figure 7.3. So let's take a look at figure 7.3, which is down below. And you can see that the layout is very similar to your spreadsheet for shift encoding. What are the differences? There's a difference here. You have to include an A inverse. Well, you also have to include an A. That's something different. You have to include A and A inverse. You also have here affine and affine inverse. So the layout is the same. You're still going to take plain text, convert it to numerical. That's the very same as in your as shift encoding. For instance, here where you turn the ciphertext to numerical, that's also the same as shift encoding. And then turning the affine into plain text, that's also the same as shift encoding. Now, what's new here? The new aspects are the numerical to affine. This is new. And numerical to affine inverse. That's also new. So how are you going to make these changes from numerical to affine and numerical to affine inverse? Well, you have to make use of the affine encoding and decoding functions. These are described way back. I think it's page 190. So let's go up there, see what's going on. All right, here we go. All right, here is your affine encoding function. Okay. So this is the function that you're going to use, the formula that you're going to use right here, pretty much like this, in order to go from numerical to affine. Now just to note, this is another way of writing it. This here means multiplication mod 26, and the circle plus means addition mod 26. So this formula has the very same significance as this formula, it's just a shorthand. Right, so that gives me the affine encoding function. You're also going to need the affine decoding function. And that's down here. This is the formula. I'm going to ask you later to prove this, but this is the formula. Don't need to worry about proving it right now. How would you express this in spreadsheet format? Remember, that's multiplication and subtraction mod 26. So when you do it in the spreadsheet, you're going to have to use the mod function. It's A inverse times C minus A inverse times B. And all that is mod 26. Now, of course, in your spreadsheet, you can't type in A inverse and C and A inverse and B, but you can refer to those cells in the spreadsheet that contain these values. For instance, if you need A inverse, going back to the spreadsheet, you will simply click on the A inverse cell, which is way down there. You'll simply click on the A inverse cell here. In the formula for shift, you'll need an A. You'll just click on this cell here. So you refer to the cells to get you the values that you need. Okay, now to make use of your spreadsheet, notice that you needed A and you also needed A inverse. Now these were numbers that in exercise 29 you would have to enter by hand. For exercise 30, this gives you a way to find the inverse of any A under multiplication. Okay, and we can find the inverses basically by making a multiplication table. And that's what you're actually creating here. You're taking the numbers 0 through 25 and you're going to make a multiplication mod 26 table. Right. Notice the use of fixed reference, the dollar signs here. What this is going to do is it's going to fix the column A for the first number and fix the row 2 for the second number. Because whenever you're doing a multiplication, in this multiplication table, you're going to be using numbers from column A and numbers from row 2. So that's why there's a dollar sign in front of the A and a dollar sign in front of the 2. If you type this formula in the first cell and then fill down, and then grab all the cells that you filled down and then fill right. So you fill down first, and then grab all these cells and select the whole table and fill right, then you can fill the entire table basically in a couple clicks of the mouse. All right, so that's how you do exercise 30. That's how you do exercise 30. Exercise 39, of course, will be very similar, just using 29 instead of 20. You can put that on a separate sheet in your same workbook. Now, exercise 32 is another variation on the same theme. In this case, we're going to do polyalphabetic coding. So let's go back and take a look at the polyalphabetic coding. Back several pages. All right, so here we go. Polyalphabetic coding also has an encoding function and a decoding function. And you're always doing multiplication mod 26. All right, so whenever you do a multiplication, matrix multiplication, you're going to be doing multiplication mod 26. Here's the encoding function, and here is the decoding function. Okay, so how are we going to use that in this context below? Notice that in the spreadsheet that I gave, we only have encoding. I didn't ask to include decoding. You can use the same spreadsheet to encode or decode. Let me just write the encoding function here. The encoding function was A times P plus B. A is your matrix, and B is your vector. And P is a pair of numerical text. Numerical text elements. Okay. So, for instance, when you're encoding this cryptology, notice how I arranged the letters CRYPTOLOGY. First, I want to convert these letters to numbers. Okay, so the C converts to 2, the R converts to 17, and so on. You've done that before. The arrangement is just slightly different, but you can use the same formulas. All right, now how do you get this encoded numerical here? How are you going to get this formula? Well, this formula here is the encoded form, so you're going to have to use this formula AP plus B. So let me say, for instance, what formula am I going to put in here? Well, that's going to be equals. We start with equals. We want to multiply this matrix times this vector and then add this vector. And we're all doing it all mod 26. So let me just start off with a mod, because that's how we're going to compute it. All right, so how do you do the matrix vector multiplication? Well, if I multiply this matrix times this vector, the first entry of the result, the entry that goes here, is going to be the first row times the column that I want to multiply. Let me get rid of some of this junk. There's too much garbage here. Okay, so I'm going to have equals mod, and I'm going to put a 26 at the end. Now this 15, as I said, this 15 is going to be the first row times this column. That's how you multiply matrix times a column vector. So how do I do that? Well, I have the first one here is A2. Okay, and then I have times, and this number here is going to be F8 plus B2 times F9. And that's going to give me the first entry of my AP. Right. I also have to add the B. Where's the B? Well, the first entry of the B is right here. It's plus E2, and that's mod 26. All right, so that's going to give me my first entry. Problem: what about fixed references? Where do I put the dollar signs? Solution. I always want to use the same matrix and the same vector. Okay, so I can put dollar signs for the matrix and dollar signs for, this is also the matrix here, and dollar signs for the vector. Okay, so that would be the formula you put in here. Actually, you can do it a little more fancy, but I won't get into that. Now you're going to have a similar formula for here, and I want you to try that. Again, you're going to be using matrix vector multiplication. This time you're doing the second entry in the resulting matrix. Once you've done that, you can fill right. And then you have your encoded message. To do the ciphertext, you're doing the translate back. That's just going to be the same old thing. Okay, use the same old method that you used before. Okay, so that's your polyalphabetic encoder, and you can use this to do all these exercises here. Now, one wrinkle is that I'm asking you to decode instead of encode. Now, how can you decode? For instance, to do the decoding of this case, we have to use the decode function. And the decode function is going to be, I think it was written this way, f inverse of c equals, well, let's go back and check and see what it is. Here we go. It's a inverse times p minus a inverse times b. Very similar to the affine, only with matrices. Now, what does this mean? This is very similar to the encoding. What it does is it replaces A with A inverse, and it replaces B with negative A inverse B. Okay? All right, so to decode, is the same as encoding, with this matrix and this shift. Okay, so how does that work practically in our example? Suppose I want to decode in this case. What I'm going to have to do is I'm going to have to compute the matrix and the shift corresponding to the decode function and use those in my spreadsheet instead of A and B. All right, let me write this again. This is A inverse times C minus, let's see, it was A inverse times B. Okay, all right. So I'm going to have to compute A inverse, and I can do that by hand, and compute A inverse B also by hand. Now, how do you compute A inverse? Well, there's a method that's told up above in the section. The method is right here. This is page 194. So I'm going to go ahead and outline it. It's this formula here. Okay. I'm going to work this out. So what I'm going to do is I'm going to snip this. And I'm going to use a spreadsheet to help me work an example. So I've opened the spreadsheet already. I'm just going to paste that here. Put it up at top. Okay. And let's try a specific example. I'll go back down to the place where it was. Okay, this example on page 200. I'm going to go ahead and snip this one too. And this is I'm going to compute the inverse of this. And like I said, I'm going to use my spreadsheet to help me do it. And spreadsheet's here, and we'll paste it here. All right, so how are we going to do this? We're going to zoom in a little bit. I think that should still be visible. All right, so I'm going to compute the inverse of this matrix A. All right. First, I have this formula, A circle D minus B circle D. All right. So what does that mean? That means that I first have to take the multiple and the minus, and then I'll have to take it mod 26. So the denominator is going to be, well, what's my A? Well, let me go ahead and put my A in the matrix first. So let me move this down. So here I'll put my matrix A, and it's here I have 13, 5, 9, 2. All right, now my denominator is going to be, according to this, it's A times D minus B times C. And we're going to want to take it mod 26. So I'm going to take mod, and here I have A times D minus B times C. Okay. Oh, there we go. It's 7. Now I need to take the inverse of 7 mod 26. All right, now by now you have your table of inverses where you should be able to compute that. Since I don't have the table handy, I'm just going to do something like this. I'm going to use a brute force method to find the inverse of 7. All right, so I'm just going to put all the numbers 1, 2, 3. Here's a little trick. If you select these two and you use that little square there, and I fill down, it will fill out the numbers up to, well, that's more than enough numbers. Okay. So in order to find the inverse of 7 by a brute force method, I'm just going to multiply all of these numbers by 7, mod 26, and see which one gives me 1 back again. So I'm going to take mod of this number times 7. Okay, I forgot the 26, so let's go ahead and put the 26. Okay, so that doesn't work. Let's fill down and see what happens here. All right, well, here's my fill down. And look at here. 15 is my inverse of 7. Okay, so that tells me what my inverse of 7 is. I'm going to go ahead and highlight that. Okay, so here's the inverse. Okay. All right, so what does that buy me? At this point, I now have this term here. I have this term here. So here I'm going to say a matrix multiplied by inverse. Okay. What I need to do now is multiply every entry of A. Well, no, it's actually not the every entry of A. So here, I'll just call this inverse matrix, sorry. Okay. I'm going to take these entries and multiply it by the inverse that I found. Okay. So what does this say the upper left-hand corner entry is? It's going to be equal to D. Now what's D? D is the original matrix entry in the lower right-hand corner. So the upper left of the inverse corresponds to the lower right of the original. So I'll take that. Okay, and remember I have to multiply this by the inverse of 7, which is going to be 15. I'll just put that in by hand. Okay. This next one is going to be, what's this? Negative C, so it's going to be negative. What's C? C is the lower left-hand corner, so I'll put in a 9 there. This is also times 15. Okay. Here I'm going to have, in this corner, it's minus B. B is the upper right of the original matrix, so that's minus this. And because of this formula, I know I multiply it by 15, so I multiply by 15. At this point, I want to have the upper left-hand corner, which is this, multiplied by 15. Okay, I'm not quite done yet. I want to take this mod 26. I should have taken it mod 26 originally, but it really doesn't matter. So let's just say inverse matrix mod 26. Okay. So I want to take this matrix that I've computed. Well, first let me type in the mod, and I'll take this matrix entry, and then I take that mod 26. Now, since the formula is going to be the same for all entries, I can fill down and fill right. One way to fill down is grab this little square, fill down that way, and grab the little square, fill right that way. Okay. So this is the matrix I will use for decoding. I will encode with this matrix. It's the same thing as decoding for this matrix. Okay. So let me just emphasize that. Encoding with A inverse is the same as decoding with A. Okay. All right, that's the important point. All right. Now I also need to find A inverse B. So I need to take inverse matrix times B. I can do that down here. Here's my inverse matrix, and here's my vector B. Okay, so here I'll put vector B. Okay, and that's 14 and 18. Okay, this spreadsheet is not completely, really nicely organized, but it gets the job done. Let me move it up so you can see what I'm doing here. So if I want the inverse matrix times B, that's going to be a column vector because it's a 2 by 2 matrix times a vector. All right, so let me go ahead and do that. How do you do 2 by 2 matrix times a vector? Well, you take the first row times the column. That's going to give you the first entry. And then you'll take the second row times the column. That will give you the second entry. All right? So first row times the column is first row times this one plus this entry times this one. Okay. Now, if I want to get the second entry in my inverse matrix times B, it's going to be equals this entry, second row of the matrix, times the column. Whoops, I forgot to put the times. So we'll do this times this plus this times this. Right? So that's going to give me my inverse matrix times B. All right, so I have to take, so I'll take A in times B mod 26. I need to get the answer mod 26, so I'll take equal mod of this result, 26, and I'll take the same thing for this one. Okay, and that gives me my A inverse times B mod 26. All right, so these are the two things I'm going to use in my spreadsheet. How do I use this information? Well, back to the problem. I want to decode this message. What that means is I'm going to put the A inverse that I just computed in my spreadsheet. I'm going to have to put this A inverse in for A, because that's the matrix I'm going to use for basically, like I said, encoding with the inverse is the same as decoding. So for this is for problem, which problem is that? For problem 32A. So for problem 32A, I'm going to replace this with, what was that matrix again? 4, 3, 21, 13. 4, 3, 21, 13. Okay? All right, now, I want to replace this also. What do I replace this by? Well, be careful. I had to remember the formula here. The inverse formula has A inverse C minus A inverse B. Okay? What I computed in the spreadsheet here was A inverse B. It would have been better if I computed minus A inverse B, but that's okay. I can just go right into my formula and replace this, I can use negative numbers. It's not the best, so I would replace this with the negatives of these, minus 6 and minus 8. I would replace this one with okay. So you go ahead, run this spreadsheet. If you've done the spreadsheet correctly and you put the matrix, this matrix here, and this vector here, and you put this in for your plain text, then what will come out is your decoded text. Okay. So I'm not really concerned that the words are not matching up, but I just wanted to show here that you can actually use an encoding spreadsheet also to decode, as long as you use the inverse matrix and the inverse vector. Okay, and you can do the other problems that way. Furthermore, you can do some of the earlier exercises that way. Save you a lot of time. You don't have to do it manually. Okay, that's it.